Hello, for this FDPI activity, I have selected the course Automatic Control Engineering and topic Mathematical Modeling of Control System. My name is Sairaj Mirji. I am Assistant Professor in Mechanical Department of WIT Solapur. Before moving to this topic, I just want to explain what is meant by mathematical model of the system. The set of mathematical equations describing the dynamic characteristics of the system is called mathematical model of the system. So most of the control system contain mechanical or electrical or both types of elements and components. To analyze such system, it is necessary to convert such system into mathematical models based on transfer function approach. From mathematical point of view, models of mechanical and electrical components are exactly analogous to each other. Not only this, we can show that for given mechanical system there is always an analogous electrical network exists and vice versa. So moving ahead, that there are some control system analysis and design. The steps there are some steps which have to be carried out. So first step is modeling. There are physical laws and identification methods, the 2 points it is mentioned. Step 2, analysis, stability, controllability and observability. Step 3 is control law design. Step 4, analysis. Step 5, simulation. The simulation may be using MATLAB, Fortran and Simulink, such as. Step 6 is implement. So we are focusing on step 1, where mathematical modeling of the system is focused. Moving ahead, analysis of mechanical systems. There are 2 types of motion, that is translation motion and rotational motion. See, a mechanical system in which motion is taking place along a straight line, such systems are called as a translational type. There are some elements which we have to consider in this translation motion, that is mass, spring, friction. Same as that of rotational motion, we have to consider some elements such as torque, moment of inertia, friction, stiffness, angular displacement and angular acceleration. So there are some analogies such as force voltage analogy and force current analogy. So before dealing with this, we should know what is actually meant by force voltage analogy and force current analogy. But for that, we should know what is analogous systems. See, in between electrical and mechanical systems, there exists a fixed analogy and there exists a similarity between their equilibrium equations. Due to this, it is possible to draw an electrical system which will behave exactly similar to the given mechanical system. This is called electrical analogous of given mechanical system and vice versa. So in force voltage analogy, if you see, there are some relations between force voltage analogy as it is shown in the slide number, this next slide, that is electrical quantity and force current and force voltage analogy. So voltage in force current, if you see, for force current analogy, the force is analogous to current, and force voltage analogy, definitely the force is analogous to voltage. So due to that, it is named as force voltage analogy and force current analogy. In force voltage analogy, the force in mechanical system and voltage is in electrical system is analogous, and definitely if you see in force current analogy, it is in the way that force is analogous to current. So apart from that, there are a variety of elements that we have to consider. That resistance R is inversely proportional to friction or damping coefficient, that is for force current analogy, and for force voltage analogy it is directly proportional, that is it is directly analogous to friction. Capacitance, if you see in electrical quantity, in force current it is analogous to mass, but in force voltage it is inverse to spring constant. Similarly for inductance, similarly for transformer, if you see this table, definitely you will get it that how they are analogous and how it is should be shown. So in this presentation we have seen what is analogous system, what is analysis actually of mechanical system deals with. Two types of motion we have seen, translation motion, rotational motion in brief, and also we have seen the table and the relation between force current analogy, force voltage analogy with the electrical quantity. Thank you.